Hello my friends and welcome to this new practical activity where we're going to build together this time the hierarchical clustering algorithm. And the case study for this model will be the same as for k-means because the purpose of hierarchical clustering is to give you an extra clustering model to compare to k-means so that you can at least have two clustering models in your toolkit for clustering, and therefore we're going to work on the exact same data set, same problem, that model trying to understand better its customers by finding some patterns which are clusters in the data. Alright, so let's do this. First, let's make sure everyone here is on the same page. I give you the link to this folder containing the whole structure of the course with all the codes and data sets in the previous articles. Make sure to connect to it. And now we're all going to go into part 4, clustering, to this time tackle the hierarchical clustering model. And we're going to start with Python as usual. Alright, so as I've just told you, we're going to work on the same dataset, mall customers, right, where each row corresponds to a customer, and for each of these customers, well, the mall gathered some info like the customer ID, the jar, male or female, the age, the annual income, and the spending score. And we're actually going to work only with these two features, the annual income and the spending score, to identify these clusters, but this time with hierarchical clustering. Alright, so exactly the same, and therefore let's proceed directly to the implementation. You have it right here, hierarchical clustering.ipynb, which you can open with either Google Collaboratory, as we're about to do, or if you don't like Google Collaboratory, you can open it with Jupyter Notebook. Alright, so choose your favorite IDE, and for Google Collaboratory lovers, well, follow me here to open this implementation in Google Colab. Alright, so right now it is loading the notebook, laying out the notebook, and there we go. So that's the hierarchical clustering implementation. As you can see, it follows the exact same structure as k-means. We first import the libraries, we then import the dataset exactly the same way as how we did for k-means. We select these two columns of index 3 and 4, which corresponds of course to the annual salary and the spending score. So exactly the same, we won't re-implement this together. And then this time, instead of using the elbow method, like with k-means, well, we're going to use the dendrogram to find the optimal number of clusters. And I will explain not only the implementation, we will re-implement this together, and also I will explain how to find that optimal number of clusters in this graph. And finally, we will train the hierarchical clustering model on the dataset using the agglomerative clustering class. And finally, we will visualize the clusters exactly the same way as what we did with k-means. And actually here the code is exactly the same. The only thing that changes is the name of that dependent variable which we create, right? Because still with hierarchical clustering, we're going to create that dependent variable, but this time instead of calling it yk-means as we did for k-means, we're calling it simply yhc. And therefore here it's exactly the same code with only that different name for that created dependent variable. So we won't re-implement this either, we'll just keep the code, and therefore there we go, we're only going to re-implement two cells, which is this one, to build the dendrogram and figure out that optimal number of clusters, and to build a hierarchical clustering model and train it on the whole dataset. Are you ready? Let's do this. And in order to do this, we have to create a copy of this notebook because this is in read-only mode. And therefore, we're going to go to File here and then click Save a copy in Drive to indeed create a copy of this notebook. Perfect. All right. So there we go, that's our copy. Now we can modify it, now we can re-implement it, but as we've just said, we won't re-implement everything, we will just re-implement these two cells here. First, the dendrogram, how to build it and how to read it, and then of course, well, how to build the hierarchical clustering model on the dataset. And then we keep the other cells because they're exactly the same as in k-means. And if you want, let's just, remove this so that we don't see the final result. And perfect now, all right? All you see here is exactly the same as with k-means. The only thing that will change are these two cells, which we will re-implement together. Okay, perfect. So first step, let's just execute these two first cells here. And to do this, we need, of course, to upload the dataset. So let's click this folder here. Now it is connecting to a runtime to enable file browsing, in your computer, in your machine. And in a second, we should see the upload button. There we go, upload. And well, I'm already in the k-means folder, but let me show you again the whole path. So that's the folder you were given at the beginning of each section, including this one, hierarchical clustering, which you could download on your machine. So I hope you have it right now. Otherwise, you would just need to go back to the previous article. And now we're all going to go inside. Then we're going to go to part 4, of course. Then section 25, hierarchical clustering. Then Python. And then there we go, molcustomers.csv. This will upload the dataset into the notebook. And so now we can run these two first cells, first importing the libraries. And now that we have pandas, we can import the dataset, which at the same time creates this matrix of two features containing only, let's see in the dataset, containing only the annual income and the spending score. In other words, X is just these two columns here with all the rows, okay? All right, so data preprocessing phase done. Now we can focus on the heart of the hierarchical clustering model, which is first to build the dendrogram to indeed find the optimal number of clusters. And of course, the optimal number of clusters that will result from this dendrogram will be the same number as the one we found with k-means, meaning 5 clusters. But I will explain how to read the dendrogram in order to indeed end up with an optimal number of 5 clusters. All right, so that was the introduction. And as you know, I like to take it step by step. So we will implement that next step of building the dendrogram in the next tutorial. So get ready. And until then, enjoy machine learning.